Hello, everyone. Well, first of all, I work in Netronome. I'm the maintainer of the Polmo driver for Netronome NICs. And this talk is about some potential hardware offloads that we could have with DPDK. It's not just about Netronome. It's things that I'm going to talk here are in the DPDK roadmap. So I think the timing is good. And just make it clear, we don't have that support in DPDK yet, but we could have it. And the idea here is to discuss how this could be done and which changes will be required in DPDK. And also for starting a discussion about how to do it. So just a brief introduction to our technology. Netronome Atelier cards, the key point here is we have a highly programmable chip. So we have processing units in the chip. And because this programmability, we have flexibility for doing new offloads, more complex than the generic ones that most of the NICs have out there. And things like, we can have things like OBS offload. We can have eBPF offload. We have P4, vRouter, or virtual offload. So my talk is mainly about OBS and eBPF offload. And I will have a last slide about virtual. So most of the people here, I think, know about OBS, which are the reasons for using OBS in virtualization, and also which is the main problem with OBS kernel. And this is because the limitations in the kernel forwarding performance. This is not the best solution when you work with gigabit cards, 10, 40, 25, 100 gigabit cards, because those limitations don't allow you to get all the possibilities in the hardware. So with OBS DPDK, you can solve that problem. So before talking about OBS DPDK offload, I want to talk about how we solve this in Netronome with OBS kernel. So different things to talk here. As you can see now, VMs are talking directly to the hardware. This is the key, okay? So with this architecture, the performance that you can have inside the VMs is almost native. So what the NIC can give you, okay? Second thing is we have a new component, a new OBS component inside the NIC. And ideally, all the packets going through the VMs, going from the VMs and to the VMs, are not going to go through the kernel. Are going to go always, the data path, the fast path is in the NIC, okay? There are some cases where this component in the NIC doesn't know how to do with the packets, usually the first packet in the flow, and then it needs to put that packet up to the OBS kernel, just as the OBS kernel does in the same case, but putting the packet up to the OBS OCR space. So for that, we have these netdev representers that are between the OBS kernel and the eBPF. And we have one netdev representer per BF. So we assign one BF, or more than one, that's the simple case, one BF to a VM. And we have a netdev representer created by the PF for solving this special case, the slow path. Okay? And the other point interesting to discuss is the TC, the Linux traffic control component that is being used for the flow offload. Okay. So the flow offload can go to the OBS, but through the TC flow offload that has been added to the kernel recently, that allows to make it transparent. So if the driver if the TC for that netdev has support for flow offloads. The flow can be inserted there. If it's the driver with XDP, that I will talk in a second, you can put the offload there, the flow there, and if the NIC support flow offload, the flow can go to the NIC. Okay, so this TC offload is key for our design, and as you will see, this is what we want to use in a hypothetical DPK OVS offload with our technology. So one main problem with this, one problem that you could say this architecture has is the VMs talking directly to the NIC, because for some deployments, what you want to have is VMs being agnostic of the hardware, so using virtual. So in this case, with talking directly to the hardware with a specific driver, that is not accomplished. So we have a potential solution for that with this virtual offload, but our current solution is using DPDK, not DPDK OVS, but DPDK intermediate step. So VMs are not talking directly to the NIC, but through a DPDK app that is doing this redirection. Okay, so we solve this in this way the problem of using virtual inside the VMs. But this is not DPDK OVS. But what we could want to have is the same architecture with DPDK. So we all know, well, I guess most of you know why to use OVS DPDK, and the main reason is performance. There are other reasons, but I'm not going to talk about them. But of course, this performance comes with the usage of resources in the host. That for some situations, for some cases, it could be good enough, but sometimes it's not so easy to adjust the system for using the right resources, for having the right bandwidth that those VMs, those tenants require. So you can solve this problem with software using resources in the host, but maybe there's other solutions that is use the hardware, the NICs, for doing the offload and avoiding then to use resources in the host. So this is the obvious DPDK graph, and the main point here is to notice that the kernel is not involved at all. So all is done in user space. So because the benefits of using DPDK, we all know that this is better, and the results, the performance, the test also say that. So SROV, this is the way SROV is usually used, how this is usually used with DPDK. So it's not the VMs are not talking, that they are not using SROV, but they are using, like our solution, as I explained before, a two-step journey to the NIC. Okay. So what about offload? With obvious DPDK, we solve the problem of performance, but what about offloading this obvious functionality? Does it make sense? Well, first of all, there have been some recent patches to the obvious mailing list for doing partial offload. So you use part of the hardware possibilities for doing the classification. You put that hint about the classification inside the MBUF, and when the packet goes to the DPDK OVS, it doesn't need to do the classification. Just use this hint for applying the action. This is good. I think they have really good numbers. Boost in performance really important. The main problem is this is just for not so. So you can't have the same for VM to VM. So I can guess this is not ideal for all the options. So with full offload, well, doesn't make sense. Of course, because what you want is to be able to use resources in the host as much as possible. So because, for example, you can have different tenants, and you can have SROV for some tenants that are paying more, and then you can have virtual.io with other tenants. There are other reasons, security. We don't have, as I said, we don't have a solution yet about this. Maybe we can have that. But what I want to discuss, so this is the same architecture we have with the kernel, but with DPDK. So we require representers as well as with the kernel. And the VMs are talking to the VFs. So it is about SROV, and we have representers. And well, there's another part that is how to do the offload of the flows. Well, this is what I was talking about. You want to have both. You want to have SROV if you need it, or if your tenants require that, and you want to have also the flexibility of virtual.io. So what does DPDK require for supporting this? Well, this is how the way we solve the representer necessity that we have. We have the PF, the NFP PF doing multiplexing. So we are using just the queues in the PF. The firmware is sending with the packets metadata for the PF doing the multiplexing to the right representer. And well, we are using the RT ring library for doing this enqueuing and dequeuing. Okay, so it works. It was experimental work. We are using the same TX function for all the representers with some logs, but we are also working on the TX logless implementation. So there are some API proposed to the DPDK for representers, but this is just for having the control of BFs from the PF. So it's not about the data path. How to implement representers is not a problem. We could have a generic library from the DPDK, or we can implement something completely internal in the POMO driver, because we require to do, we need to do this multiplexing. So we need to have all of that knowledge inside the PMD. The point is, DPDK, the ideal is to have this being completely transparent. So obvious DPDK using representers as if they were real devices, real virtual functions. So I can see a reason for maybe to modify the plugin mechanism for adding these representers. To have probably the need to have a transparent naming, because the people working with OBS DPDK doesn't want to get confused, or it's better to think to have the same names in any case. And probably the most important point is how to do the flow offload. Okay, we support the flow in DPDK. This is control data. This is not the data path. This is the control. And we in Netronome, we think that we should leave the control to the kernel. So we have a solution for doing the flow offload through the kernel, through the TC, and we think we should follow this approach if we implement this DPDK offload with DPDK. So for that, we will need probably a bifurcator driver. If you remember, I make yesterday a question about this to Mellanox, because this is not easy. Because if you try to do this to the kernel guys are going to say, no, because this is for DPDK, so we don't want to have that bifurcator driver in the kernel. So there are some problems to solve here. So, well, I think I'm going to talk now about eBPF offload. It has 20 seconds for 10 minutes or for 15? OK. Well, eBPF offload. I think you know about eBPF. If not, well, this is a mechanism for sending programs to the kernel from user space. It was implemented initially for filtering packets. And eBPF is an extended implementation for doing more things, using this architecture for doing things like tracing. And for example, and what is interesting is about XDP, to have the possibility of doing something with the packets as soon as possible, instead of waiting for the packet going through all the TCP IP. The idea is to do that as soon as possible. Where? In the driver. So you can attach a program, a eBPF program to the driver, and to do things like dropping the packets or maybe forwarding. Okay? There's a lot of work in the kernel for adding functionalities to the eBPF. I'm not going to talk about this. So the question about DPDK is, do we need eBPF with DPDK? Because this was initially for sending programs from user space to the kernel, but we are user space, so do we need the same? Could it be instead of eBPF, because it's a language, to use another language? Also, well, personally, I think it would be interesting to have that support, because probably the same eBPF programs could be used with DPDK or with the kernel. So I can see a repository of eBPF programs for doing filtering or forwarding, and people using these eBPF programs, whichever, with the kernel or with DPDK. So I think it would be good to have this compatibility. The point is, I don't know if this is going to be feasible, because all of these new features that are being added to eBPF in the kernel, so maybe because we are not the kernel, at one point we are not going to be able to maintain this compatibility. But of course, there are people using DPDK, implementing their own network stacks with DPDK. So having XDP with DPDK, whatever it will be the implementation, I think is a good thing, because you will have the POMO drivers handling packets as soon as possible for dropping packets, for security reasons, or for other possibilities. By the way, there are libraries for using eBPF in user space already, so that will not be a problem at all. So as Netronome, we have the possibility of having this in the NIC. Okay, so that is, we have already that with the kernel. And the idea is to, as you can see on the left, you have XDP, the eBPF program, attached to the driver. So the packets, when they arrive, that eBPF program is executed for filtering, forwarding. Okay. The problem is, in that case, this is good. It is better than going through all the TCP. But the problem is, you are using resources in the host, and you are using resources in the PCI. Okay. So with eBPF offload, you can have the same eBPF program in the NIC, fully compatible, and then the same dropping or forwarding can be done inside the NIC. So you are saving resources in the host, and you are saving PCI bandwidth as well. OK, so the last one is about virtual offload. That I think is a really interesting one, but we are starting working on this. The idea is to have virtual I/O in the VMs, so they are agnostic of the hardware, but they are really talking to the hardware, because the hardware is virtual I/O friendly. Okay, so this is good for performance reasons, for deployment of VMs. There are some things to work on, like the migration, and well, maybe in DPDK, for supporting this, we need to modify parts like the vhost, probably, or maybe the IOMAU configuration. Okay, so just last remark, there's another option that instead of doing full virtual offload, to have partial virtual offload that is DPA. That is an Intel idea. I think there are some presentations about that in the web. And that's it. So if you are interested in all of these TC offload eBPF, there's an event next month that you are invited for talking about the last additions to the kernel in this regard. So questions?
I think we'll have to do questions in the panel because we're a little bit over.
Okay.
But would you like to thank you, Alexander, with a round of applause?